All right, if you've been anywhere near the world of AI lately, you've probably heard the term vector database thrown around everywhere. Today, we're going to break down exactly what that means, and more importantly, why it's the secret engine powering some of the absolute smartest AI out there. So let's start with a different way of thinking about search. Forget just typing in keywords like dog. What if you wanted to search for a vibe, or find every picture that has the same feeling as a certain pair of shoes? How could you find a song just by humming a few bars? This isn't about looking for exact words. This is about searching for meaning, for similarity. And this isn't some small niche problem. We're talking about a huge chunk of our digital world. It's estimated that a whopping 80% of all the data we're creating today is unstructured. You know, all the images, the videos, the audio files, those massive PDF documents. It's a chaotic, messy, but incredibly valuable universe of information that we're trying to make sense of. And that's where we hit a wall. See, traditional databases, the kind that have been the backbone of businesses for decades, they were built for neat and tidy data. Think rows and columns in a spreadsheet. They just weren't designed for this new, unstructured reality. They get totally confused. Okay, so look at this picture of a dog. In a traditional database, to make this searchable, you'd have to manually tag everything. You'd make a column for animal and type in dog, another for color and type golden. But this is so brittle, right? It's slow and it misses all the nuance. What if you wanted to search for happy golden retrievers playing in a park? Your simple little tags are going to come up completely empty. And that really is the heart of it. Old school databases think in exact matches. They can find a specific word in a specific column, no problem. But they have absolutely zero conceptual understanding. They don't get that a king is related to a queen or a throne or a castle. They just don't get the meaning. So to solve this, we needed a completely new approach, a real breakthrough, a way to teach computers to understand the meaning behind all our messy, unstructured data. And the big idea? It was to turn meaning into math, using a genius concept called embeddings. So how in the world do you teach a computer about meaning? Well, you translate it into the only language it truly understands, numbers. And that's exactly what a vector embedding is. It's basically a long, long list of numbers, a vector, that acts as a unique numerical fingerprint for a piece of data. An AI model looks at an image or reads a sentence and captures its very essence, its semantic meaning, in this list of numbers. Let's make this real. Check this out. The AI model learns to connect words with all these different abstract concepts. So when it sees the word king, it might give high scores for ideas like masculine, royalty, and power. But for queen, it gives a low score for masculine, but keeps that royalty score way up there. And here's the magic part. We didn't create these columns. The AI learned to identify these features all by itself, across hundreds or even thousands of dimensions. And this is the big aha moment. When you plot all of these vectors in this massive, multi-dimensional space, something amazing happens. Things that are similar in the real world, like king and queen or dog and puppy, they naturally end up close to each other. They become mathematical neighbors. All of a sudden, you've turned fuzzy, abstract meaning into concrete, measurable distance. Okay, so we've got this awesome new way to represent our data as numbers. What now? Well, we need a new kind of toolbox. We need a place to store and search all these vectors. We need a database that was built from the ground up just for this job. And the difference is night and day. A traditional database, it's like a super organized filing cabinet, perfect for storing things like customer orders in neat rows and columns. But a vector database, it's more like a brain. It's built for AI to store these rich numerical fingerprints and search for things that are similar, not just things that match perfectly. And, it's really important to get this straight. We're not talking about some simple search index here. A true, full-blown vector database is a complete industrial-strength system. It handles all the stuff you'd expect, adding and deleting data, filtering, security, and scaling up to billions of vectors, all while plugging right into the AI tools that developers are already using. All right, so we've turned our data into vectors, we've stored them in this new special database. So how does the search actually work? How does it pull off that magic trick of finding close enough? And yeah, that really is the billion-dollar or maybe the billion vector question, right? I mean, if you have to check your search against every single item in the database, one by one, it would be impossibly slow. So how on earth do these systems find the right answer in the blink of an eye? Well, first you have to define what close even means. And for that, we turn to math. The database can use formulas like cosine similarity, which measures the angle between two vectors, or Euclidean distance, which is just the straight line distance between them. These calculations turn the vague idea of similarity into a hard number. But like we said, just running these calculations for every single vector one by one, no way. That's a brute force approach and it would be a total crawl. The real secret sauce, the thing that makes this all possible, is incredibly clever indexing. This is where something called approximate nearest neighbor, or ANN, comes into play. These algorithms are genius. They basically create a super smart map of all your data, organizing it into clusters and building shortcuts. So instead of checking every house in the country, your search can instantly jump to the right city, then the right neighborhood, and just check there. And here's the brilliant trade-off. It sacrifices a tiny, insignificant bit of perfect accuracy for a massive gain in speed. It finds a good enough answer almost instantly, which is exactly what AI applications need. Okay, so this technology is clearly cool, but what's the killer app? Where is it making the biggest waves right now? Well, it's by giving AI something it desperately needs, a reliable long-term memory. And that's done with a technique called Retrieval Augmented Generation, or RAG. We all love large language models like ChatGPT, but they've got a couple of big problems. For one, their knowledge is totally frozen in time. It stops the day their training ended. And even worse, they hallucinate. They confidently just make stuff up because they're built to sound plausible, not necessarily to be factually correct. And this can be a massive issue. Look at this example. A user asks a pretty simple question about their car, but the LLM has no idea what the real manual says, so it just invents an answer that sounds right. It's plausible, but it's completely wrong. This isn't just unhelpful, it could actually be dangerous. Okay, so here's how we fix that with RAG. When the user asks their question, the first thing we do is turn that question into a vector. Then we use our vector database, which we've already loaded up with the actual Volvo user manuals, to instantly find the most relevant sections. We then take those real facts, bundle them with the original question, and hand it all over to the LLM. And look at the results. It is a night and day difference. Now, because the LLM has the actual facts from the real manual right in front of it, it gives the perfect, correct answer. It's not guessing anymore. It's acting like a smart assistant that has actually read the manual. The hallucination problem? Solved. So when you boil it all down, this is the key thing to remember. Vector databases are the missing piece. They are the bridge. They give these powerful AI models a reliable, searchable, long-term memory that connects their incredible general intelligence to the specific factual data of the real world. Your company's data, your personal notes, anything. And that just changes everything, doesn't it? It moves AI from being just a clever conversationalist to being a true partner in knowledge work. Which really leaves us with one huge, exciting question to think about. Now that AI can genuinely understand the meaning behind our data, what's the next great challenge we're going to ask it to solve?